In this video, we're going to talk about solving systems of equations by substitution. One thing that you'll need to do is make sure that the expressions that you're given, one of them needs to be solved for a variable. You can solve for x or you can solve for y. It doesn't matter, but one of them has to be already solved, or you need to put it in a form y equals or x equals. So let's start with this first example. So a system, remember, is two or more equations So let's start with this example. Y equals 3x and y equals x plus 2. They are both set up as y equals, so all we need to do is say, well, if y equals 3x, then we'll take this 3x and substitute it or plug it in for y in the second equation. So this will turn into, if I were to replace this y with 3x, I would say 3x equals x minus 2. Now I need to combine like terms, so I'm going to move the x to be on this other side, so minus the x, I'm left with 2x equals a negative 2. And of course we divide to get x all alone, and x equals negative 1. Now, the goal for solving a system of equations is to figure out the point in which they intersect, or an x value and a y value. We can't just solve for one. We have two missing pieces here. So take the x value that you found and plug it back in to either of the equations. It does not matter which one. Y equals, I'm choosing equation number 1 here, 3 times the x value that I got was negative 1. Therefore, y equals negative 3. That's really all there is to substitution, but your problems will get more difficult than that. So let's take a look at the second one. Here, I have the first equation is solved for y. We have y equals, and the second equation is in standard form. So, since I already know that y equals this information, I'll take this information and plug it in the second equation for y. It is y. So 4x plus x plus 1. I usually like to keep this in parentheses just in case there were a negative out here that I was going to have to distribute. Then continue writing, equals 6. So all I did was rewrite this, and instead of putting y, I put in what y equals in the first equation. Now in this case I didn't need the parentheses because there's no negative here to distribute, so we'll have 4x plus x plus 1 equals 6. Combine your like terms. So this is 5x plus 1 equals 6. And now move the 1 over, minus 1 minus 1. 5x equals 5. Therefore, x equals 1. I need to find out what y is, so I'll take my x equals 1, and I'm just going to go back to the first equation because that looks easy to work with, and I want to solve for y. Y equals, well, I got x, I got 1. X plus, so I plugged in my 1 and said plus 1, so y equals 2. You want to make sure that you get an x value and a y value. Now let's take a look at this example. Both of these equations are in standard form, ax plus by equals c. So what I want to do is solve one of the equations, not both, but one of the equations I want to solve for a variable. And you get to choose this. You can choose x, so in this case I could move everything away from this x and have everything on one side and x equals on the other side. Or down here I could solve for x or y. I could solve for y up here. It doesn't really matter. If you don't want to work with fractions, you need to try to avoid anything that has a coefficient in front of it. So this one has a 2 in front. That means in the end I'm going to have to divide every number that's in here by 2. And if you don't want to create fractions, you want to try to stay away from that. It's not always avoidable. You will sometimes have to do problems like that. So what I'm going to do is I'm going to choose to solve for x in the first equation. So I'm going to set it up as x equals, I'm going to move the 2y to the other side, so it's negative 2y minus 1. And now that I have it solved for a variable, I know what x is. X is this information right here. So I'm going to plug it in for x in my original equation. So I've got negative 2y minus 1, that was the x value, that's x, minus y equals 5. So again, I don't need to distribute any negatives because there was nothing on the outside of x, so I have negative 2y minus 1 minus y equals 5. Be very careful with any negatives and when you plug things in. Make sure you plug in correctly. I've got a negative 2 here and a minus y. Negative 2, that's understood to be back here. This negative y is understood to be negative 1y. So we have negative 3y's minus 1 equals 5. Move the 1 over. Negative 3y equals 6, and divide by negative 3. And therefore y equals negative 2. Now I have y, but I do not have an x value yet. So plug this x value, or this y value back into either equation, it doesn't matter. I'm going to plug it into the second one, x minus, be careful here, the y value that I have is negative 2, so it's going to be x minus negative 2 equals 5, which is x plus 2 equals 5, and therefore x equals 3 when you move the 2 over. Okay, and then the next one. So as I look across, I could solve for x here because if I divide by 2, everything's divisible except for 1. I would have to work with a fraction, 1/2. That would be okay. I could solve for y here, which would be very easy because I wouldn't have to divide by anything, just move everything over. Well, it doesn't matter which one you choose, just choose one. So we'll say y equals, I'm going to move this 2x to the other side. Remember, you cannot combine if they are not like terms. So negative 2x minus 4. Now I know what y equals. Y equals this. So this is y, and so I plug it in here. X plus the y value equals negative 7. Again, I don't have anything to distribute here, so I'm just going to take away the parentheses. And since I'm saying plus a negative, I'm just going to go ahead and say minus 2x minus 4 equals negative 7. This would generate a negative 1x by combining like terms, so I'm just going to write negative x. Add the 4 to both sides. We have negative x equals negative 3. But we don't want to solve for negative x, we want to solve for x. So divide everything by a negative 1, and x equals 3. Now take your 3 and plug it back into either equation as long as you plug it in for x. I'm going to plug it into the second one. So I'm going to say 3, because that's x, plus y equals negative 7. Solve, minus the 3, y equals negative 11. Sorry, 10. Negative 10, negative 10. Ah! Mistakes can't count. There you go. You have your x and your y. The back side of this paper has some word problems. We'll be talking about word problems in class, so I'm not going to cover them in this video. So if you have any questions about how to solve by substitution, please stop by and let me know. All right. See ya.